Let's look at finding some derivatives with negative powers. And the good news here is that we can still use the same rule that we've been using so far. So if our f of x is written as ax to the power of n, then that means that f prime of x, which is a derivative of f of x, is going to be nax to the power of n minus 1. So this is the rule we've been using all along. And as I said, we can actually use that with negative powers as well. So if we have an f of x with negative power, all that means is that this number, x to the power of something, this exponent, is negative. So in this case it's negative 2. And if we want to differentiate this, we're going to do exactly the same thing, but we have to remember that this is still a negative number. So when we multiply by this in front, so the n comes down in front here, so we multiply by this in front, it's negative 2 rather than 2. And then we've still got times x, and then when we're reducing the power by 1, we get minus 2 minus 1. So we're going to get minus 3 is going to be the power. So this is what we get when we differentiate this one. Let's do another one here. If instead f of x was equal to 1 over x to the power of 5, well, that doesn't look like it's got a negative power because it says x to the power of 5. But 1 over x to the power of 5 is the same as x to the power of negative 5. So we can't actually differentiate this as it is because it's 1 divided by x to the power of 5. So we're first going to have to write it as x with a negative power. And in this case, it's just going to be x to the power of negative 5. And now we can differentiate it. So we get f prime of x. And the minus 5 comes down in front. So minus 5x. And then we're going to reduce the power by 1. So let's write it as minus 5 minus 1. And then we can simplify to say that's the same as minus 5x to the power of negative 6, because negative 5 minus 1 is negative 6. Alright, another example, a bit longer this time. If our function gives us 2 over x squared plus 3x cubed minus 1 over x to the power of 6. Okay, so this is a bit of a mixed one because here we have a positive power and here we have positive powers, but they're in the denominator of a fraction, or they're being divided by, which means that they're going to end up being negative powers. So there's a big mixture, but we can deal with that. So 2, we're just going to write the number down, and then 1 over x to the power of 2 is the same as x to the power of negative 2. So you can see it as moving this x squared from the denominator into the numerator. We basically just add a minus sign in front. So we're changing the sign of the power when we move this thing across the division line. So we're moving it up here, and that means that we get a negative power. And the 3x cubed we're going to leave. And then with the 1 over x to the power of 6, we saw here that 1 over x to the power of 5 was x to the negative 5. So that's going to give us x to the negative 6. So this was still f of x. And now we're going to find f prime of x, which is a derivative. And as usual, we're going to multiply by this number in front. So we got minus 2 times 2x. And the power is going to be minus 2 minus 1, which is minus 3. And we got plus 3 times 3x. And the power reduced by 1, so it becomes 2. And this one we have to be a bit careful because we've got minus, and then we've got negative 6 times x to the power of minus 6 minus 1. Okay, the reason I say we have to be careful is that we've got minus and negative, because minus and negative is going to make a plus. So we'll do that when we get to it. So we've got minus 2 times 2, which gives us minus 4x to the power of minus 3, plus 3 times 3 is 9x squared. And now this is this one where we've got minus and negative. That becomes plus 6x to the power of negative 7. Okay, one more example. If we have our function 5 over 2x plus 3 over 4x squared minus 1 over 3x cubed. So this one looks like a bit of a mess, because we've got fractions and we also have negative powers. So we're going to have to take these x's up into the numerator and change them to negative powers. But the fractions themselves are actually okay, because all we do is we write them down. So the first fraction was 5 over 2. So we got 5 over 2 x to the power of minus 1. And then here our fraction is 3/4. So 3/4 x to the power of negative 2. And finally the fraction here is just 1/3 x to the power of negative 3. So this is still f of x, because all we've done is we've simplified the function that we started with. And we're now going to differentiate. So f prime of x is going to be equal to this power we take down in front. So we've got minus 5 over 2 x to the power of minus 1 minus 1, because we're reducing the power by 1. And then we've got plus minus 2, let's put that in brackets, times 3 over 4 x to the power of minus 2 minus 1. And finally we've got minus negative 3 over 3 times x to the power of negative 3 minus 1. And let's tidy it up a bit. We got the first one is minus 5 over 2 x to the power of negative 2. And then this one we're going to have to multiply the minus 2 by 3, which gives us minus 6. Minus 6 divided by 6 is just minus 1. So we just get minus x to the power of minus 3. And then here, minus 3 divided by 3 is minus 1. But because we're taking away minus 1, that gives us plus x to the power of minus 4. In case you didn't spot the deliberate mistake in here, it was the 4 here suddenly turned into 6, which is obviously wrong. So this 4, it should still be a 4 when we get to here, which means that we're going to have negative 6 over 4. So negative 6 over 4 is going to be our fraction, and that simplifies to minus 3 over 2. So we should actually have a 3 over 2 in front of this x to the power of negative 3. So the answer is this here at the bottom.